Good morning, dear students. I'm Dr. Jyotirmayi from the Department of Chemistry. Today, we shall discuss about another important alkaloid, that is strychnine. As we already know, alkaloids are medicinally important compounds, that is organic compounds, usually obtained from the plant sources. Today, we are discussing about strychnine, that is obtained from Strychnos nux vomica. This is the botanical name of the compound, Strychnos nux vomica. Here you can see the leaves and the fruits of the plant, which are having good medicinal importance. So actually, we use the homeopathic drug nux vomica. The name itself is completely given to homeopathy medicine, that is nux vomica, which is having very good medicinal purpose. So here, if you can see, there is a statement given. ఈ చెట్టును తాకారో ఇక అంతే. So అత్యంత విషపూరితమైన చెట్టు. So this is so highly poisonous. So we need to be very careful when we take strychnine as a medicine or in the form of a medicine. It should be taken in very small quantities. So this is the actual structure of strychnine. Here you can see 1, 2, 3, 4, 5, 6 rings are present. So here you can see the benzene ring attached to a heterocyclic ring. So 6-membered benzene ring is attached to 5-membered heterocyclic ring. This ring is called as the indole nucleus. Due to the presence of this indole nucleus that is represented in the red color, it is called as indole alkaloid. Coming to the molecular formula of strychnine, it is C21H22N2O2. So 21 carbons are there, 2 nitrogens and 2 oxygens are there. We have to find out the nature of the nitrogens and oxygens. As you look here, the nitrogen is tertiary in nature. This is directly attached to 3 other carbons. Here also the nitrogen is attached to 3 other carbons. No hydrogen, this is also tertiary in nature. And coming to the oxygens, the carbon is attached to oxygen. This is the keto group. One oxygen is in the form of ketone and another oxygen is in the form of ether. So oxygen flanked by 2 carbons on both the sides. So the other carbon is in the ether linkage of a 7-membered ring. Okay, that is about the functional groups. So 2 nitrogens are in the tertiary amine form and 2 oxygens. One oxygen is in the keto form, the other oxygen is in the ether linkage in a 7-membered ring. So this comes under indole alkaloid. Coming to the biological importance. So strychnine is available in the form of a pill. So it can be used for human ailments, for diseases, for pains and all, it can be used. And another thing is strychnine is used primarily as a pesticide, particularly to kill rats. As I have already mentioned, it is highly poisonous. That's why we can use it as pesticide to kill the organisms, micro or small organisms, and also to kill rats. And uncommonly strychnine is used and it is found to mixed with street drugs, heroin and cocaine. We know, we'll be listening in the news, drugs and all. Actually the name of the drug is completely changed. Actually the drug is used for the purpose of human ailments, whereas the drugs that we see in the news are that drugs that are used to be for addiction. So we know that heroin and cocaine are the drugs that are used. Along with heroin and cocaine, small quantities of strychnine is mixed with them. So as we have already seen, it is a crystalline solid and it is deadly poisonous. So we have seen that there are 2 nitrogens. It contains nitrogen, that's why it is called as alkaloid. And another point which we have already seen, that it is a indole alkaloid because there is a benzene ring. Adjacent to the benzene ring, there is heterocyclic ring having 5 members, and among 5, one is the nitrogen. And when we discuss the structure of strychnine, which we have seen in the previous slide, the indole nucleus is represented in the red form. And this strychnine is obtained from the seeds of Strychnos nux vomica, which we have already seen in the last slide. So, as we have already discussed, the molecular formula is C21H22 N2O2. And strychnine is a monoterpenoid indole alkaloid because this contains the indole nucleus and it is also having isoprene units. That's why it is called as monoterpenoid. So this is having keto substituent at 10th position. We have already seen that there is a keto group. Strychnine on reduction, it gives strychnose alkaloids and converts the lactam carbonyl into a methylene group. So that is converts strychnine into strychnidine. So this strychnine, which is having the carbonyl group, undergoes reduction and gets converted into strychnidine. So strychnine reacts with benzaldehyde in basic alcoholic media to furnish a faintly yellow benzalidine compound. As this reacts with benzaldehyde, it indicates the presence of active methylene group. So the presence of the active methylene group is confirmed by the reaction with the benzaldehyde. Thus, we can confirm the structure for strychnine. Now, we shall discuss the synthesis of strychnine. So, as I have already mentioned, the quantities of the compound that are obtained from the plant sources are in small quantities. That's why when we extract the alkaloids from the plant sources, the amount of compound that is obtained is very meager, small scale. That's why we study the structure and synthesize in the laboratory in a large scale. So we are discussing about the synthesis of strychnine that takes place in the laboratory. So here we start from phenyl hydrazine. Phenyl means the benzene ring and NH2 is hydrazine. So we start from phenyl hydrazine and the other reactant is 3,4-dimethoxyestophenone. This is again phenyl ring having 2 methoxy groups, third and fourth, and COCH3, that is acetyl group. We call this as 3,4-dimethoxyestophenone. So phenyl hydrazine reacts with 3,4-dimethoxyestophenone, undergoes a condensation reaction. They just combine with one another with the loss of water molecule. Thus, the indole nucleus is formed. So, as I have already mentioned, benzene ring attached to a 5-membered heterocyclic ring is called as indole nucleus. So, here the indole is formed. So, this first step is called as the Fischer-indole synthesis. So, indole nucleus is formed. This is called as 2-varatyl indole. That is, nitrogen is in the first position. This is the second carbon. So on the second carbon, there is varatyl group. Okay. What is varatyl group? Benzene nucleus with methoxy groups. So this is called as 2-varatyl indole. Now, this 2-varatyl indole undergoes Manish reaction. We studied about Manish reaction in the first year, second semester name reactions. So here we can see it undergoes the Manish reaction. So that they react with the amines in the presence of water to form the corresponding product. So here you can see this is dimethylamine. So 2-veratyl indole reacts with dimethylamine. So this dimethylamine attaches to the indole nucleus. So this is the product form. There is no change in the other parts, just the dimethylamine molecule adds to this particular carbon atom. Then it again further changes into cyanide. So what happened here? The position of the nitrogen changes. Actually here you can see the nitrogen, whereas in the position of the nitrogen you can see the carbon. So the nitrogen that is present here attached to two methyl groups is converted to the cyanide group. So a cyanide is formed. Then this cyanide further undergoes reduction to form the amine. Okay, so there is a triple bond between carbon and nitrogen. The triple bond is reduced. Automatically, carbon adds the hydrogens and nitrogen also adds the hydrogens. Amine group is formed. That's why amine is formed. This amine reacts with the aldehyde of the ester. So this aldehyde of the ester reacts with the amine. So here the hydrogens and oxygen move out as water molecule. Dehydration, removal of water takes place. So the nitrogen attaches to the carbon through a double bond. You can see nitrogen attached to the carbon through a double bond. Here we have 3 rings, 1, 2, 3 rings, and ester is formed. We call this as tricyclic ester. This tricyclic ester on cyclization. Cyclization means ring closure. Okay, so in the presence of tosyl chloride, it undergoes cyclization. Here it is a tricyclic ester. Here you will get the tetracyclic compound. Tri means 3. 3 rings are present. We call it as tricyclic ester. This on cyclization, that is ring closure of this molecule, you will get another ring here. So finally we will get tetracyclic compound. This tetracyclic compound on reduction, here you can see the double bond. So in the place of double bond, hydrogens are added. The bond breaks here. One hydrogen adds to this nitrogen and one hydrogen adds to this carbon. So you can see the addition of hydrogens. That's why, because of the reduction, you can see the formation of this particular compound. Next. So this compound, that is the reduced compound which we have seen in the previous slide, on treating with acetic anhydride. So on treating with acetic anhydride, you can see the formation of the ester. And also the amide is formed. Here you can see NH reacts with acetic anhydride to form the amide. Amines react with acetyl group of the acetic anhydride to form the amide. Amide is formed. This amide on oxidation. This amide undergoes oxidation. So here you can see number of double bonds. So whenever there is a double bond, on oxidation the double bond breaks. One oxygen adds to one carbon, another oxygen adds to the other carbon. So here the bond breaks. You can see a double bond oxygen is formed here, a double bond oxygen is formed here. The ring opens. Here the benzene ring undergoes oxidation. The ring opens. Next, this particular compound again undergoes ring closure. So here ring opened, this ring is opened, and here this ring is formed automatically. So one ring opened, and in the next step another ring is formed. This compound on hydrolysis. Hydrolysis means hydrolysis. Addition of water. Lysis means breaking down. On adding water, what happened? The ester group is present. Here the bond breaks. Hydrogen adds to this CO group and OH adds to this. So you will get acid. So this on hydrolysis gives acid group. And here also the methoxy. Here also the bond breaks. Here also you can see the bond breaks, and here also the bond breaks and hydrogen adds to this oxygen and OH adds to this oxygen. So in this step on the ring closure, you got this compound. This compound on hydrolysis, ester is converted to acid, methoxy is converted to hydroxy. This again on further treating with acetic anhydride. Again it is treated with acetic anhydride. On treating with acetic anhydride, again you can see that methoxy group is formed. Here OMe is formed and acetoxy group is formed. Then again here you can see Deichmann condensation. This is also a ring closure. So here the ring is closed. So here actually you have 1, 2, 3, 4 rings. Here 1, 2, 3, 4 rings. Whereas here if you see 1, 2, 3, 4, 5. 5 rings are present. So on Deichmann condensation, another ring, that is here there is another ring, that is the 6-membered ring also closes. So here you can see this particular compound on further treatment. So what happened, this particular compound is changed into tosyl. So this on treating with tosyl chloride, the hydrogen is replaced by the tosyl group. So this particular compound further undergoes changes. So on treating with the benzyl mercaptan, this is the benzyl mercaptan. So on treating with benzyl mercaptan, here the carbon is protected. The next step, this group is lost. This particular compound that is present here, that should undergo reduction. What is meant by reduction? Addition of hydrogens. So here there is a 6-membered ring. This double bond must not be present. For this we add the hydrogen. So the double bond breaks. This carbon adds 1 hydrogen and this carbon adds another hydrogen. So thus on reduction we'll get this particular compound. This on further hydrolysis. Hydrolysis means addition of water. Here the bond breaks. If the bond present between oxygen and methoxy, the bond breaks, hydrogen adds to the oxygen and hydroxy adds to the methanol. Automatically here the bond breaks, you will get OH. Here you can see OH. The remaining structure, there is no change. Only simply here the reaction takes place. Now this particular compound again on treating with acetic anhydride in pyridine followed by selenium oxide in ethanol, it gets converted to another compound. So here the ring closure takes place. Let us go to the previous slide. Here you got 1, 2, 3, 4, 5 rings are present. By treating with acetic anhydride in pyridine and selenium oxide, this ring also closes. Another ring closure takes place. That's why here you can see 1, 2, 3, 4, 5, 6. Sixth ring also undergoes cyclization. So sixth ring is formed. Here you will get one keto group and here also you will get another keto group. This on treating with sodium acetylide, that is CH triple bond CNA. On treating with sodium acetylide, the acetylene molecule is added. Here you can see 2 carbon atoms are added. CH triple bond CH is added. So this undergoes reduction. That is CH triple bond CH, 1 pi bond breaks. So you can see 1 sigma bond and 1 pi bond is present. So hydrogens are added to one carbon and the other carbon. So here you can see the reduced product. This on further reduction. Now the reduction takes place in a different place. That is, here the keto group is reduced. So C double bond O is reduced to CH2. So almost we got the carbon skeleton, but few more changes should take place. So in this step, another ring, a 7-membered ring must be formed that should have the oxygen. If that is formed, the synthesis of strychnine will be completed. Already we have 6 rings. The 7th ring is 7-membered and the 7th ring should have the oxygen. For that purpose, this is allowed to undergo allylic rearrangement. So in the previous classes, we have discussed about allylic rearrangement. In allylic rearrangement, the position of the double bond changes and the position of the hydroxy group changes. If you see here, now in the next step, the double bond that is present here shifts to this position and the hydroxy group shifts to this position. That is basically called as allylic rearrangement. What is allylic rearrangement? In allylic rearrangement, the position of the double bond shifts to the other position automatically. The position of the hydroxy group changes. Here the pi bond shifts to this carbon and hydroxy shifts to this carbon. Thus, a double bond is present here, hydroxy is formed. Now, the final step will be the ring closure again. In the presence of sodium hydroxide and methanol, the ring closure takes place and a 7-membered ring is formed. Thus, finally, the medicinally important, highly poisonous strychnine is synthesized. That is about the synthesis of strychnine. So, what are the important or repeatedly asked questions about strychnine? So, what is strychnine and which type of alkaloid is strychnine? And what is the medicinal importance or the main purpose of strychnine? And then what is the structure of strychnine? It is an indole alkaloid and there are 2 tertiary nitrogens. One oxygen is carbonyl group, the other is in the form of ether in the 7-membered ring. So what are the heterocyclic rings in strychnine? So we can see indole nucleus and another nitrogen is in the 6-membered ring, that is the pyridine ring. So finally, another important question is elaborate the synthesis of strychnine. So these are the textbooks that we have used and we have got the information from the google.com and we have downloaded the images from Google also. So this is a very important alkaloid to be remembered. So you have to study the structure and synthesis of strychnine. So thank you for your patient listening.